Good morning, everybody. Welcome to the third and final segment on analysis of series magnetic circuit. In this segment, we will be seeing numerical where the effect of leakage flux is taken into account. So, what is actually leakage flux? Leakage flux is defined as the magnetic flux which does not follow the particularly intended path in a magnetic circuit. Consider this figure. So in this figure, I am having an iron core with a air gap, and this core is wound with coil having n number of turns, and it is carrying a current I. So when a current I passes through this coil, a flux will be set up around this coil. So we will be expecting all the flux created to follow the path through the core and finally reaches the air gap. But what actually happens is that some of the flux will be leaked into the air gap, into this surrounding air, and this flux won't be reaching the air gap. And this flux that is leaked into the surrounding air, it is known as the leakage flux. The flux in the air gap is usually known as the useful flux. So here what we can say is that flux in core will not be equal to flux in air gap since some flux has already leaked. Here we are introducing a new term, that is the leakage factor lambda. Lambda is given as total flux by useful flux. So total flux is actually the flux in core and useful flux is the flux in air gap. The value of leakage factor or lambda is usually greater than 1. Now let's move on to the numerical section. Please read this question. So in this question it says that there is a circular iron ring having a mean circumference of 1.5 meter. That is, we can write L equal to 1.5 meter and a cross-sectional area of 0.01 meter square. That is, area of cross-section capital A equal to 0.01 meter square. Then a socket of 4 mm wide is made in the ring. So this means it's actually the air gap. So length of the air gap that is given as 4 mm, that is Lg equal to 4 into 10 raised to minus 3 meters. Calculate the magnetizing current required. So we have to calculate the value of I to produce a flux of 0.8 milliweber in the air gap. So here the air gap flux, that is 5G, is given as 0.8 milliweber or 0.8 into 10 raised to minus 3 Weber. And it is also said that the ring is wound with a coil of 175 turns, that is N equal to 175. Assume relative permeability of iron as 400, that is mu r is given as 400 and the leakage factor is given, that is lambda is given as 1.25. So in this question lambda value is given. That means flux in core will not be equal to flux in air gap. So we know that the leakage factor lambda equal to total flux by useful flux or flux in core by flux in air gap. So that is phi I by phi g. The value of lambda is given as 1.25. So 1.25 is equal to phi I by 0.8 into 10 raised to minus 3, which is your phi g value. So the flux in iron ring phi I will be equal to 1.25 into 0.8 into 10 raised to minus 3, which can be obtained as 1 into 10 raised to minus 3 Weber. So this is actually a series circuit. So for a series circuit, what we can say? Total MMF will be equal to MMF of iron path plus MMF of air gap. That is total MMF, that is Ni, equal to phi I Si plus phi G St. Here flux is different. Flux in core is different from flux in air gap. Now our aim is to find the magnetizing current I. For that we need to find Si as well as Sg. So that is the next step. So reluctance of air gap Sg is equal to Lg by mu 0 A. All the parameters are given in the question. By substitution we will be getting it as 3.18 into 10 raised to 5. Then next we have to find the reluctance of iron ring, that is Si, that is equal to Li by mu 0 mu r into A. But in the question we have only provided with the mean length of the ring. What we need, the length of flux path in the iron. So that can be obtained as Li equal to L minus Ld, because the mean length of the ring means that will also include the air gap. So we will be getting Li as 1.496 meter. Substituting for Li, the reluctance of the iron ring can be obtained as 2.98 into 10 raised to 5. Now substituting in the equation Ni equal to phi I Si plus phi G Sg, we will be getting the magnetizing current I as 552.4 divided by 175. That's equal to 3.157 ampere. So this is the magnetizing current that is required to produce a flux of 0.8 milliweber in the air gap. So when we are given the leakage factor, only one thing we have to keep in mind, that is flux in core will never be equal to flux in air gap. All the other steps remains the same. Thank you.